So I want you to rate it and tell me, is this a numerical data or is a categorical data? And you want to think about it, is this a categorical data or numerical data? Remember, categorical data, you can always classify your subjects or maybe participants into yes versus no group, 1 or 0 group, like a female versus a male. And the numerical data, they means whether numbers or not, right? Height, salary, number of people. This is a categorical variable, and let's take a look at why is that. Okay, so if you voted for categorical variable, you have to tell me how you can classify your individuals into yes versus no group. Okay, so how would you classify your individuals as yes versus no group? How would you do it?
1 ticket and up versus no tickets.
Yes, right. Did you guys all hear what he said? 1 ticket, more than at least 1 ticket versus no ticket at all. So 2 groups. Okay. And another hint for you guys to tell, this is a proportion problem dealing. We are working with categorical variable is because I see the word proportion, right? Okay. So this is not always true. Whenever you see proportion, doesn't mean this is a categorical data. You do want to read. You do want to read carefully. Okay, so we know that this is a categorical variable. And before we jump into the question, what I like to do is I like to write out a bunch of information, right? For example, sample size. Okay, what is the sample size here? Do we have a sample size? I mean, probably not at this part, but you can go to part A. Do we have a sample size?
150.
150, right? Okay, so small letter n, 150. And how about population proportion? Do we have a population proportion? 0.15, right? Because 0.15 has nothing to do with the sample you collected. They were just saying, you know, on average, the proportion of individuals is going to be 0.15. So this is more general compared to the 150 sample you selected, right? So this is going to be the population proportion. Okay, I'm going to ask you another question. How about the sample proportion? How about the sample proportion then? Do we have sample proportion? Do we know it? We don't, right? And that's why you were asked to show the sampling distribution. And for the later part of the question, you can see what is the expectation of the sample proportion and what is the standard error of the proportion. We don't know exactly what the sample proportion is, but we know according to central limit theorem, sample proportion may follow a bell curve. Okay, may follow a bell curve. I'm going to write out this theorem here. I'm going to put the theorem here. And in order to use it, we have to verify. Okay, so I'm just going to move. In order to use it, we have to verify the assumption is checked or not. Okay, so to check the assumption, you are going to use n multiplied by p, right? It's going to be n multiplied by p. Okay, so sample size is 150. Okay, so this is my working. So black. Okay, 150 multiplied by population proportion, which is 0.15, right? Okay, if you do that, which I haven't calculated yet, this is 22.5. I think the question, the assumption only asks you to have at least 10, right? I think the question says at least 10. The assumption says at least 10. Okay, so this is more than 10. So again, this means assumption is met. We can use the CLT for proportion. Is this part clear how I did it?
Yeah.
Good. Okay, I'm going to copy this one to here. I think this flows better. Okay, and so this is the result we have. And now we're going to calculate the expectation and then the standard error. So the expectation is going to be this one, and the standard error is going to be this part. Is this clear? Right? Okay, so expectation of the sample proportion. Expectation refers to the center of this bell curve. I want to draw it out because I think a lot of students are confused. Whenever we talk about sampling distribution, I've taught this class for 5 years. I've seen all different kinds of problems. If you're able to ask a question I haven't seen before, I will be super impressed. Okay, but certainly this question has to be relevant, right? Has to be relevant. It can't be something not relevant. That's why no one asked. Okay, so let's take a look. I've seen a lot of confusion in this part. So P bar, okay. So P bar also follows a bell curve. Okay, it's possible the P bar also follows a bell curve. Okay, so I'm gonna just write it down here. This is the distribution of a P bar. It's gonna follow a bell curve because we have already verified assumption is checked. And this bell curve, it's just like any bell curve, any normal distribution, it has a center to it, which refers here. And the center of this bell curve is just gonna be at P. And for our problem, this P is nothing but 0.15. Okay, students get confused because they think, wait a second, this is the center, this is a mean. How can you have a mean to be a proportion? Okay, so this part is confusing because we are not talking about the population mean here. What we are talking about is, we are talking about the center of the P bar. The P bar is going to follow a bell curve. Bell curve is just like any normal distribution. The center of that normal distribution can be at 2, can be at 8,000, can be at 9,000, 90.2, or any number that you can have. It could certainly be centered at 0.15. It can be any real number. I mean, yeah, real number, right? So the center of this bell curve is 0.15. Okay, and so the expectation is just 0.15. The standard error of the proportion is nothing but this square root number. You're gonna plug them in. Okay, you do want to make sure you want to bring a calculator and calculate it, right? Okay, so let's take a look. I have the numbers here, so you can calculate it out. I'm just gonna copy it here. The standard error. Okay. Goodness. Standard error is just a square root. You see a square root. P 0.15 multiply 1 minus P, which is 0.85, over 180, right? 180. You guys see 180. So plug this into your calculator. This is a square root of the entire thing. Okay, very, very important. Bring a calculator with you. Okay, if you do that, okay, you're gonna get 0.029155. Fairly small. That means the spread is small. Are you surprised the spread is small? This is a difficult question. Are you surprised to see the spread or the standard error of the proportion is so small? Are you surprised or not? Why is it so small? Why? Anybody wants to give it a try? Why is it so small? How do we determine the spread of it? We use this equation, right? How big is the sample size? The sample size is much bigger than before, right? It's 150. This is a big number. And that's why the spread is fairly small, right? Okay, averaging reduces variability when you go to a bigger sample size. Okay, when you go to a bigger sample, clearly it's going to be more centered towards the mean, right? Okay, is this part clear how I calculate the expectation and how I calculate the standard error of the proportion?
Yeah.
Good. Okay, so let's work on a problem, right? Let's work on a problem. I'm gonna clear this all my drawings, okay, so you can see it. Okay. So there's one problem to this one. Okay, so they were asked what is the probability? Okay, so several things you want to focus on: probability, sample proportion, sample proportion. Okay, so you want to write it out. Okay, I don't know why is it bold. Okay, so probability of the sample proportion. So sample proportion is P bar. Is P bar. I have it here. Okay, so we want to, again, it's going to be within plus minus, so it's going to be between two numbers. I'm going to change everything to black. Okay, population proportion within plus minus 0.03 of the population proportion. Again, I'm just going to use the population proportion. Population proportion is 0.15. We have it here, 0.15. Within plus minus 0.03, so that's going to be 0.05 plus 0.03, right? Is this part clear? And on the left hand side, it's going to be 0.15 minus 0.03. Oh, sorry, typo, right? And now you can calculate it again. Okay, so this is going to be okay. So you can do the math on your own. This part is easy. And now Do you think you can look up those two numbers from your Z table right away? Do you think I can look up 0.12 and 0.18 using our Z table?
No.
Do you think I can do it? Is this a Z-score, right? Is this a Z-score? This is not a Z-score, even though it looks like they are a Z-score. I mean, you are able to find 0.18 in your Z table, but this is not a Z-score because you are talking about X bar, oh, sorry, P bar. This is typo. You're talking about P bar. This is your actual observation, what you observed, what percentages you have observed. This is not a Z-score yet. This is not a Z-score. Okay, you have to convert this to Z-score. So how do I convert it to Z-score? So, okay, so let's try. Z-score equals to 0.12. I'm going to start with the left one. So you can convert it to Z-score. Oh, sorry, my bad. This is observation. It's 0.12. You can convert it to its corresponding Z-score. What you need to do is you're going to use the observation, which is 0.12. You're going to minus the mean. And the mean is just right here, 0.15. Remember, we calculate this part. Okay. And then you have to divide it by the standard error, right? Standard deviation. Okay. So that's going to be this number you found. Is this part clear how I did it? Okay, so this is an additional step you have to do. Use your calculator, you should be able to find. This is going to be minus 1.0290. Okay. You can do the same thing for the next one, observation, which is 0.18 as well. You can find the Z-score for it. Everything is fairly similar. You can plug those numbers in. And what do you think is going to be the Z-score this time? You don't have to use your calculator because if you see there's symmetry between those two numbers, this is 0.03 minus the mean, and this is 0.03 plus the population proportion, right? Okay, so it's just going to be positive 1.0290. Okay, hopefully this part is clear. Okay, and now let's go back to our question. So we have a 2 Z-scores. We're going to write it down here. I'm going to round it to 2 decimals. Remember, for our Z table, it's only accurate to 2 decimals, right? Now you can write. You can see how I'm writing. The notations are always different as well. So I was writing a P bar. Now I changed to Z to remind myself this is a Z-score. You can use it. You're going to use the same method as what I did before. I'm going to find it twice on your table. First time you're going to find 1.03. Okay. I think it's well, go away. Oh, hold on a second. 1.03 is right here. You guys see it? 1.03, 0.8485. You can do the same thing for the negative one as well. And I've already done that. And the numbers are given right here. Right. Okay, I just want to quickly, describe what's going on here. Hopefully you agree with me. This is a categorical variable because what we have here is, so they were asking, let's see, okay, so how many of them actually cooperated and responded? So you can classify the subjects into people who responded versus who didn't. So this is a yes or no question. And so it's a categorical variable. Sample size is 400 because you collect the 400 of them. Population proportion, this is the 40%. And I had students ask me, is 0.375 sample proportion? It's actually not. We are trying to figure out what the distribution of it. Distribution means a shape. It could be any number. We don't know exactly what it is, but we are trying to compare it with, right? Okay. So in order to do that, what you need to do, you're going to use the same formula as what we did before. So this is what we did. And you're going to plug in all the numbers. And so you're going to have P bar sample mean is going to be follow normal. And the center of it comes from this one. And the standard deviation is just plugging in those numbers here. Right? Okay, so I did the math. I was able to calculate that part. Once you figure out the mean and the standard deviation, everything will be much easier. Because, for example, this question asks you, what is the probability a sample proportion will be at least 0.375? So you can write it out a probability of a sample proportion, that's P bar. Okay, so I'm going to just copy it down here, 375. So this is what you need to do. And you probably remember from today's class, you don't want to look up this one right away from the z-score, right? You don't want to do it. So what you want to do is you want to convert the 0.375, right? Okay, so I'm going to use here. So observation, okay, hold on a second. Observation, this is what we observe, we want to compare. Is this one, how can we compute it to z-score, right? Okay, so you're going to use 375 minus the mean, which is this one, and divided by standard deviation, which is 0.02249, right? I don't want to drag you guys any longer, and let's see. So I think so the number is actually right. Okay, so you can go back and fill in. This is negative 1.02, and this is to the right. You see, it's more than, so it's to the right. You should be able to figure that one out by reading your table, right? Okay, remember all the answers are posted on Canvas later on. You should be able to check it out, and feel free to let me know if you have any questions.